Hello friends, I welcome you to my YouTube channel MacPM. In today's video we will solve a numerical problem related to fluid mechanics. So you can see that this is a problem related to water jet striking tangentially at a fixed curve plate. So let's read out the problem and let's note out the parameters which are given in the question simultaneously. A jet of water of the diameter d is equal to 100 mm. So d is given as 100 mm, which is equal to 0.1 meter, because 1 meter is equal to 1000 mm. Moving with a velocity of 20 meter per second. Velocity is given as 20 meter per second. Strikes a curved fixed plate tangentially at one end at an angle of 30 degree. So this theta angle is 30 degree. The jet leaves the plate at angle of 20 degree from the horizontal. So this is 20 degree, this angle. Find the force exerted by jet on the plate in the horizontal and vertical directions. So we are assuming that this plate is frictionless and there is no loss of energy. So plate is velocity of v1 and v2 are same at inlet and exit. So it is given that it is water. So rho is equal to density is 1000 kg per meter cube. So we know that F force is rate of change of momentum, which is equal to initial momentum m1 minus final momentum n2 upon time, which will be equal to mass into velocity is momentum. So m1 v1 minus m2 v2 divided by time. Now m1 and m2 are same because there is no loss of mass in this plate. So it will be equal to m v1 minus v2 divided by time. Now m by t is mass flow rate, which will equal to volume flow rate into density. So density into volume flow rate, which is equal to area into velocity. So mass flow rate is rho av. So it will become rho av v1 minus v2. This is the formula for force. Now if we break the velocity in two components, horizontal and vertical, then it will be v cos theta, this is v sin theta, and here also v cos theta and v sin theta. So first let's calculate fx. In x direction or horizontal direction, we have to calculate the force. Fx is rho av v1x minus v2x, which will be equal to rho av. What is v1x? v1x is the velocity at inlet in x direction, which will be equal to v cos theta, minus what is v2x? Velocity at outlet in x direction. So here see it is in positive x direction, here it is in negative x direction. So this value will be negative. This is theta 1, this is theta 2. So this is theta 1, this is theta 2. And this is negative. So the minus and minus will become plus. So it will be rho av. This will come out rho av square cos theta 1 plus cos theta 2. Theta 1 and theta 2 are angles 30 degree and 20 degree. So it will become rho av square cos 30 plus cos 20. This is the formula for the forces in x direction. So if we put the values, if we have to calculate area, because there is area here, so area will be pi by 4 d square, which will be equal to pi by 4 into d is given at 0.1 meter. So it will be equal to 0.00785 meter square. Now we have found out area, so we have to put the values. Rho is 1000 into area is 0.00785 into velocity. Velocity is given as 20 to the square into cos 30 plus cos 20. you have to calculate, you don't remember the value of cos 20. Cos 30 is 0.866, so we have to put the values in calculator. If you put the values in calculator, then you will find the fx is equal to 5672.34 Newton. So this is force in horizontal direction. Now similarly we have to find force in vertical direction, so it will be rho av in bracket v1y minus v2y. So it will be equal to rho av. What is v1y? Velocity in vertical direction at inlet, which is equal to v sine theta 1 minus velocity at outlet in y direction. So these two are both in positive y direction, so it will be positive. So v sine theta 2. So it will be rho av square sine theta 1 minus sine theta 2. So if we put the values, 1000 into area is 0.00785 into v is 20 to the square sine 30 minus sine 20. Value of sine 30 is 1 by 2, and we have to calculate sine 20 from the calculator. If you calculate these two values, then you will find the values of the force will be equal to 496 Newton. So we have calculated the forces in x and y direction. So I hope you understood how to solve this problem. Thanks for watching the video.